Hey everybody, it's Tuesday again. Do you remember this? My globe, my miniature planet Earth? We're going to use it again today because today we're talking about gravity. What does gravity mean? Well, gravity means when something doesn't have any other reason to go anywhere else, it goes down. But what does down mean? Well, that's a crazy question, and we're going to have to get out our Earth to check it out. Okay. I'm going to put where we live on top. And this is how we stand on Earth. And sometimes this is a hard thing to understand. This ball is Earth, and the surface of the ball is the ground that we walk on. So here's my little man standing on Earth. And he's going down, right? Like if I drop him, he's going to go towards the Earth. But what about the other side of the Earth? You know, there are people living down there too, and they walk on the Earth just like this. And to them, down means towards the Earth. But it's not any different down there. It's not like life down there is crazy because sometimes, or they may think, we're the ones on the bottom. And when we fall towards the Earth. What down really means is towards the center of the Earth. Where's the center of the Earth? Well, take a look at our globe. The center of the Earth is what we'd see if we cut the Earth in half and looked at the very middle. Imagine for a minute that this apple is the planet Earth. So no matter what side somebody's walking on, down is the middle, and gravity pulls them towards the middle. Let's find the middle. The middle is the very center, right here. And with both an apple and the Earth, it's called the core. Gravity pulls hardest on bigger objects, heavier objects, objects with more mass, we say. So bigger, heavier objects have more mass. Let's do a little experiment. Willie and Amos are going to help with this.
You see here we have a square, we have a person, we have a little bouncy ball, we have some type of, I think it's a leopard, and a Pokemon card, and this block, and a card, and a magnet tile. Which one do you think is going to fall first? I think the magnet tile.
This drawing is the drawing of all the things that are going on the ceiling. You see, there is the person. I don't know if you can tell by shape, but you've probably, because I told you. And then here's the Pokemon card. Here's a little Lego square, and here's the magnet tile. Here's the little car. Here's that little ball you saw, and then here's the animal, and then here's the cube. And this huge square is the room. And you see these little arrows are presenting like gravity.
Which one do you think is going to fall first?
I think magnet tile.
And which one do you think is going to stay up there the longest?
I think Pokemon card.
Why do you think Pokemon card?
Because it's the flattest and it's not that strong.
And Willie, what one do you think is going to fall first?
I think probably the little toy car.
And why do you think that?
I mean, it's because all the others are like plastic or paper. And that's pretty much the only one that's metal.
How long do you think it's going to take? Like 1 minute or like many hours?
I guess it's probably like 2 minutes or something?
We'll find out. Well, when gravity pulls down, it pulls down the hardest on the biggest, heaviest objects, right? Objects with more mass. That basically means biggest and heaviest. So would gravity pull down harder on a bowling ball or a piece of paper? A bowling ball. Well, that's why you don't want to be standing underneath a bowling ball when it falls, but if you were underneath a piece of paper, it wouldn't be too much of a problem. So let's think about our toys that way. What do you think is going to fall first? In my kitchen, I have a scale. This will help us figure out what is the heaviest object. And maybe that'll help us understand what falls first. Remember, our Matchbox car fell first, and then our lioness, and then this lady. So when I weigh things, we'll look at the numbers. And the bigger numbers mean it's heavier, and the smaller numbers mean it's lighter. Are you ready? This car weighs 27 grams. The lioness weighs 26 grams. And the lady weighs 26 grams too. Here are the toys that never fell at all. The tape was still so sturdy that they might not have fallen for days. Let's find out how much they weigh. The Lego piece weighs 9 grams. That's much less than 26 or 27. The Pokemon card only weighs 2 grams. The spiky ball weighs 3 grams. And the little puzzle box also weighs 3 grams. So the toys that fell sooner weigh much more than the toys that fell last. That's because gravity pulls down hardest on the biggest objects. Well, Earth isn't the only thing with gravity. Did you know that every single thing has gravity? The smaller objects have less gravity and bigger objects have more gravity. Even we and our toys and everything have gravity, but it's so little we can't even feel it. Bigger objects have more gravity. What are the biggest objects that we can think of? Well, bigger than buildings, bigger than mountains, bigger than oceans. Planets. Planet Earth pulls us all towards the center. And other planets do the same thing. So I'm going to ask you a question. What do you think has stronger gravity? A small planet or a huge planet? Well, the bigger the object, the stronger the gravity. So let's think of something else in our solar system we learned about last week. The moon. The moon is a lot smaller than Earth. Do you think it has more gravity or less gravity than Earth? Less gravity because it's smaller. Have you ever noticed that when the astronauts walk on the moon, every little step is like a huge jump? They're lighter on the moon than they are on Earth because the moon has weaker gravity. Now think about a planet like Jupiter. Oh, Jupiter is many, 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 many times larger than Earth. Do you think that astronauts are heavier or lighter on Jupiter? They're much heavier. They're about 2.5 times heavier. That means if we were on Jupiter together, well, you would probably weigh almost as much as I weigh on Earth. What do you think it's like in outer space, where there's almost no gravity? Well, the reason it seems like there's almost no gravity is that astronauts floating in space aren't close enough to the center of any planet for their gravity to feel particularly strong. So there's no such thing as down, and there's no such thing as up. There's just the direction that they're pointing. And when they move, They move until something other than gravity makes them stop in any direction. Make sure you look down in the comments to check out this totally cool video that was made in a zero gravity environment. All of this is totally real and absolutely amazing. It'll give you a better idea of what it looks and feels like to be in an area where there's no gravity.